Hello. So, in the last problem, we found out that these two ratios, AB over BC equals YX over XZ, were equivalent, which is interesting because it means we can create ratios with the same triangle in one ratio and a different triangle in the other ratio, instead of our usual ratio with both triangles in one ratio and both triangles in the other ratio. Now, let's look at part C. AB over XZ. Is that equivalent to BC over YX? Well, in the last problem, part B, we discovered that if we were to multiply the proportions out, we would have something like this. AB times XZ is equivalent to BC times YX. Now, is there any way we could get to part C from this? Well, I want AB to be over XZ, so I could divide both sides by XZ, and let's see what happens. Well, these would certainly cancel out, and we would have AB equals BC times YX over XZ. Now that didn't really get us what we wanted. We wanted AB over XZ. So I could try dividing one more time, and if I divide by XZ again, I do have AB over XZ, but then I would have to do another another XZ over here, which would lead us to this weird proportion AB over XZ equals BC over YX over XZ squared, which doesn't really look like a proportion that we've worked with or that is particularly useful. We would also want to try to get YX on the bottom of BC, but if we divide by YX on both sides, we're going to have YX here. Sorry for all the stuff, but that would just cancel both of them out, and then we'd be stuck with the YX over here. So we could keep doing this on and on and on forever, but no matter what you do, no matter how you divide it out, it's always going to get you stuck in this loop where you have two products on the bottom. So our answer for C is that this is a false claim, that those two ratios are equal. That's false. Again, we got this is true and true. And we'll just redraw ABC and Y, X, Z. Alright, AC times YX. Is that equivalent to YZ times BA? Well, if we look at our very first problem, we know that that's true. So we know that AB over YX is equal to AC over YZ. Let's do cross multiplication, and we will find that AB times YX, or I'm sorry, YZ is equal to AC times YX. And if we notice, if we just flip each thing around, AC times YX equals YZ times BA or AB. So this looks to be absolutely true. And then finally, part E. BC over BA is equal to XY over ZY. Well, let's look. BC corresponds with the side XZ. And BA corresponds with the side XY. So, can we come up with some sort of way to show that these ratios are equal? Well, we have BC over XZ equals BA over XY. Cross multiply BC times XY equals BA times XZ. And then we can divide both sides out. And so I would divide BA over to the left side. So we would get BC over BA equals, divide the XY over here to get XZ over XY. Well, does that match our formula? BC over BA equals XZ over XY. Well, that does not seem to be what we are looking for. So in this case, our answer to part E is false.